Okay, so we're getting ready to do our whiteboarding session. Everyone say hello to the world's biggest Sea Chickens fan, Mr. Justin Kress. And also to Mr. Jacob Schmidt. Hello, fellas. Obviously, sorry you missed us today, but we're recording the whiteboard sessions. And also for those of you 8th hour that are gone caroling, whiteboard sessions you'll see right here, and obviously you'll get to see all the ensuing discussion. Okay? So Dakota and Tyler, start us off. What did you guys find out from the lab?
Well, to answer the beginning question, in a chemical reaction, what do we have to do to figure out what the ratio of elements are? We need to mix volumes of chemicals in an uneven ratio, and then get rid of all the extra unreacted chemicals, and then that will give us our base compound to help us figure out the actual ratio of compound.
Okay. So then, what did you discover for your ratio?
We got 2 to 1.
Okay, how did you come up with the 2 to 1 ratio?
He did.
Do you need to go back and look at your stuff to show how you got or figure out how you got the 2 to 1 ratio?
Probably, yeah.
Okay, why don't we do that, and maybe the answer will reveal itself in the other presentations. Is there anyone that'd like to go next?
Yeah, sure. We can.
Okay, Becca, Jeho, and Ryan.
Our claim was to find the ratio, you find how many grams of each substance and then convert it to their moles. So we took the mass of the zinc, and that's 3.4 grams, and then we found the mass of the chlorine, that's 3.71, and then we converted it to their moles, so the zinc was 0.05 and the chlorine was 0.1, and then we divided the moles of the chlorine by the moles of the zinc and got 2 to 1.
Okay. So ultimately, you're finding grams of each and converting to moles of each. Okay. So then if you were to have, obviously then for the chemical compound, because obviously we got a mole to mole ratio, what's that tell us also about, if we've just got a singular compound, what's that tell us about how many atoms we have of each?
It's 2 to 1.
2 to 1. Yeah. Because a mole to mole ratio is the same as what else?
Atom
Atom
to atom.
to atom ratio. So a mole to mole ratio is the same thing as an atom to atom ratio. Okay. Another group.
Is that the part there that we were missing? The mole to mole is equal to atom.
Yep. Grady and Amanda. It was?
Yeah, it said it was 161 or something, but that would explain how we got 5 to 1.
Okay. Excellent. Okay. All right. So Grady and Amanda, go right ahead.
To figure out what the ratio of elements are, you find out how many grams of each from the product, convert to moles, and compare it to the ratio.
Okay.
Evidence, we did this to find a ratio and we got 0.1 over 0.06. So about 2 to 1, which is the accepted ratio for zinc chloride. We could have had a small experimental error to get 0.06 instead of 0.05.
Okay. Question then for you. Any thoughts on what could have been the experimental error?
Maybe not all the water taken up with it, or whatever.
Well, the bigger number on top was the chlorine, and obviously the smaller number was the zinc. Remember when you guys were doing the part 2 of the experiment? What did it mention anything about to be cautious in terms of the part 2 of the experiment?
The smoke.
The smoke.
Not much the particles escape.
So that could have lost a few particles possibly with the smoke, or I'll even admit a little bit of fault too, because obviously if I made the mistake when I was overwatching it, if I didn't get to it right away, a few of them might have been lost that way too. Okay. So, excellent job. Another group. Meeny, miny, moe. Thank you, Taylor, and Isaac, and Holly.
Yeah, I don't know. I don't know.
All right. Go right ahead.
Well, our plan was to figure out the ratio of the elements
elements, you have to find how many moles of the element you have to divide those numbers by each other.
And it came out, it ended up coming out for you then. Excellent. All right, so it ended up coming out with the 2-to-1 ratio. So you're saying, what was the original issue that you had that it came out at such a high ratio? It was something to do with molar
I
mass.
didn't have my periodic table, so I Googled the molar mass and it was wrong.
What, okay, because did it give you the molar mass of zinc chloride, or what did it give you, do
The
you
zinc
know?
one was wrong. I don't-
Okay.
It said it was 161 and it was only like 65.
Oh, okay. Gotcha.
So once we got that right, it was no problem.
Gotcha. Okay. Excellent. Way to go. Last but not least, Alyssa, Emily, and Tavi. Okay.
One zinc molecule and 2 zinc chloride molecules. You have to find the moles in the two substances and find the ratio between the two. For our evidence, we had 3 grams of zinc combined with 5.2 grams of chloride. Chlorine had 0.1467 moles and zinc had 0.459 moles. And we divided them and we got 2 to 1.
Excellent. I've got to give you guys credit, and I have no idea how 8th hours has come out yet, because obviously they'll be doing that today. This has got to be the first class, I think, in all 6 years I've been here that's gotten the 2-to-1 ratio from the experiment. So that's awesome, actually. So that means you guys did a really good job in making sure that you were keeping up with the experiment in terms of the directions and making sure you were observing to make sure you didn't get the white smoke. So excellent job, everyone. Excellent job. Okay. Did your guys' ratio also come out 2-to-1? I think it did too, didn't it? Yeah.
It,
Okay, excellent. All right, so again, ultimately, out of all this, then, the whole idea was you had to obviously react your chemicals, and then at the end, you found out how many grams of your product you had. You knew how many grams originally were zinc that you added in, so then you were able to find grams of chlorine from it. You converted both of those numbers to moles, so that way you could get the ratio of chlorine to zinc. So ultimately, our empirical formula is a mole to mole ratio. Okay, so once again, the empirical formula of a chemical, and I'll make sure to put this up on the board tomorrow, is a mole to mole ratio of elements. Okay? For homework tonight, since I know there's only about 2.5 minutes left to go, I want you to do the second half of worksheet 2. Okay, you should have done, I believe you did the first 6 problems, so now you just have to do the last 5. Okay, the second part of worksheet 2.